Big reputation, big reputation. Sorry, don't mind me. I'm just trying to win arguments, which today apparently means learning every song on Taylor Swift's Reputation. I'm usually more of a casual listener, but today my producer has hit my last nerve, and that means I'm willing to engage in petty and meaningless wars. Like if, hypothetically, my producer was fighting me on this and I had to bet, I'd say Taylor's albums have even more variety than her discography as a whole. I've been listening to the full discography, and I'm telling you, every slower Midnights has its boppin' anti-hero, every bouncy 1989 has its moody clean. No matter what kind of record she's dropping, Miss Swift hits us with the full spectrum of human emotion every time. Whether you need to shake it off or cry on your guitar, Taylor understands that variety is the spice of life. And here's the thing, it is also the spice of statistics. Hi, I'm Sabrina Cruz, and this is Study Hall, Real World Statistics. If you're like me and on a mission to prove that Taylor's albums are more diverse individually than her entire discography is as a whole, Statistics is here for you. Now, there are a lot of ways to quantify the sound of a song or an album, but one straightforward way is tempo. And if we want to figure out if there's more variation in tempo within an album or across albums in an artist's discography, we can turn to a specific set of statistical tools. To compare variation through tempo, we first need to understand how much tempos vary across an artist's whole discography. Here, that means digging into Taylor's giant collection of work, from the twangy sounds of her debut to whatever tragedy that went down on the Tortured Poets department to all of those albums in between. I'm gonna be real, she puts out music faster than a getaway car. Now, the tempo of Taylor's songs vary a lot. Her slower songs are around 60 beats per minute, while her faster songs are more like 200, and the mean is about 123 beats per minute. Swifties tell me that if I squint hard and pretend that the 2 isn't there, it becomes a 13. It's a sign. Apparently. We can also compare this variation overall to variation within each of her albums, which is what I'm comparing. Most of them have similar distributions of tempos, but we can start to see which albums are a little faster than the overall average tempo of 123 beats per minute, and which ones are slower. Like Reputation is going hard, and then there's Folklore on the slower end. Graphs that are compatible with quantitative variables like tempo and categorical variables like album name can show us different measures of variability in Taylor's songs. Like a histogram can show us how much each song's tempo varies from the others throughout the whole discography, and box plots can show us how much variation in song tempo happens between albums and how much variation there is in song tempo within each album. I need a way to decide which one of those variabilities is bigger to prove to my producer that Tay's music ebbs and flows even more within a single album than between albums. One way to do that is to look at a ratio of the two variabilities, comparing variation in an album's tempo overall against variation within each album. First, though, I'll need a way to translate those variabilities that we can see in graph form into concrete numbers that we can analyze formally. Now, I'm not gonna lie to you guys, I usually make a computer do this stuff for me, but it's good to know how things work before we turn tasks over to technology. To keep things simple, let's look at a random sample of 3 songs from 3 Taylor albums: Reputation, Folklore, and her self-titled debut album. Okay, so the average tempo of these 9 songs is 138 beats per minute, and each album has its own average tempo. We can see that both Reputation and the debut album have means greater than the overall mean, while Folklore has a mean less than the overall mean. Different album, but why you gotta be so mean? Am I right? However, the songs in each album vary around their album mean as well. Taylor's debut album has the most variation. Some songs are fairly slow, like Invisible, while others are pretty fast, like Teardrops on My Guitar. Reputation and Folklore songs vary less around their mean, staying in a narrower range of tempos, like Dancing with Our Hands Tied and This Is Why We Can't Have Nice Things are only 4 beats per minute different from one another. Now we need to compare how much each song's tempo varies around its album mean tempo to how much each album mean tempo varies around the discography's mean tempo. To do that, we first have to calculate a number to represent how much the albums vary from the discography's mean tempo. This number will measure the diversity in tempo across the discography. To find it, we need to add up the distances between the album mean tempos and the overall mean tempo. Since some of those distances are negative and we wouldn't want those to cancel out any positive distances, we square the distances before adding them up. Each song within the album gets a say in this final number, and since in this example each album has 3 songs, each of those squared differences counts for triple. The resulting number will definitely tell us when the next album will drop. I mean, it's called the sum of squares between groups and is shortened to SSG. Here each group is an album, but sometimes the different groups represent literally different treatments, like doses of medicine, and then you'll see this referred to as the treatment sum of squares, or SSTR for short. Basically, that number summarizes how much total variation there is between the overall average and each group's average, collapsing a bunch of numbers into one that we can use to make comparisons more easily. But we're not done yet. We still want to figure out whether the variability within each album is greater than the variability between albums. To get a number that represents how much the individual songs vary from their album mean tempo, we need to add up the distances between each song and their corresponding album mean. Again, we square up the differences before summing them all up. This total number is then called the sum of squared errors, or SSE for short, and that basically gives us a one-number summary of how much all the songs bounce around their album mean tempos, which again collapses a bunch of information into one number that is easier to make comparisons with, which is what Swifties are best at. Now, all of this has given us a way to describe 2 types of variability in tempo: variability within albums and variability between albums, and we can take this same approach to the full Taylor Swift discography on our way to proving that there is more diversity in tempo within each Taylor album than between all of her records, and more importantly, proving my producer wrong. Say we've got our SSG and our SSE for our full Taylor dataset. Now we want to find a way to compare these numbers, and I need you to brace yourselves because stats is always throwing letters at you. Spelling is fun! The F statistic is a ratio that compares our SSG and our SSE. It combines scaled versions of those hard-won numbers we just found to help us weigh them against one another. The F statistic's numerator represents the between-group variability. In our Taylor example, that's how much each album's average tempo differs from the discography's overall average tempo. And the F statistic's denominator represents the within-group variability. That's how much each song on an album differs from the album's average tempo. Our between-group variability is calculated by dividing the sum of squares between groups by the number of groups minus 1. That number is called the mean square between groups, or MSG. No, not the tasty kind. How much each song on a Taylor album differs from the album's average tempo, or our within-group variability, is calculated by dividing the sum of squared errors by the number of data points minus the number of groups. That number is called the mean square error, or MSE. So the F statistic is actually a ratio of ratios. A large F statistic suggests that the variability between groups is much larger than the variability within the groups. That would tell us that the average tempos of Taylor's albums are actually really different from each other. On the other hand, a small F statistic suggests that the variability between groups is much smaller than the variability within the groups. So here that would mean that the tempos of the songs on each of Taylor's albums vary more than the albums overall. So like, sure, Holy Ground and Everything Has Changed on Red don't have the same vibe, but they are on the same album. In our case, our F statistic is less than 1. Since the ratio would be 1 if there was an equal amount of variability within albums as across albums, a number less than 1 suggests that I'm probably right and my producer is probably wrong, much like Scooter Braun. Basically, it would suggest that there is more diversity in tempo within albums than between albums. We're still not ready to speak now on Taylor's album variety, but we're getting closer and there's some prep work we can do in the meantime. And just like the test statistics we've seen before, we'll need a probability distribution to help us translate our findings into a probability. Test statistics each have their own distribution for calculating p-values, and an F statistic follows, wait for it, an F distribution. Unlike the normal and t distribution, it is not symmetric. That's because, like the chi-square distribution, it skews to the right. Since the F statistic is a ratio of positive numbers, it can't go lower than 0, but it can get really, really big. Look at that right tail! That right skewed shape of the F distribution is determined by 2 degrees of freedom parameters, one for the numerator of the F statistic and one for the denominator of the F statistic. These degrees of freedom represent the number of data points that could vary in a sample and still give you the same statistic. Since the numerator represents a comparison between groups, the degrees of freedom is related to the number of groups. In fact, it's just the number of groups minus 1. So in our Taylor example, that's 11 albums minus 1, or 10 degrees of freedom for the numerator. Now the denominator represents a comparison within the groups, so its degrees of freedom is related to the total sample size. But first we need to subtract the number of groups from that total. So again, in our quest to investigate tempos of Taylor songs, the denominator degrees of freedom is 210 total songs minus 11 albums, which means 199 degrees of freedom for the denominator. Those degrees of freedom numbers should look familiar. They are what we scaled our variability measures by when computing the F statistic, and that isn't a coincidence. And as both degrees of freedom increase, the F distribution looks less and less skewed and more like the normal distribution. That's just like the other distributions that we know have degrees of freedom, the T and chi-square distributions. So if there are many albums and many songs, our distribution is going to look much more symmetric. And great news, at the rate Taylor's putting out music, that is definitely going to happen. Now, like I said, all of this info by itself doesn't immediately give us a surefire way of proving I'm right about Taylor's album variety, but it does give us the building blocks we need before we do a formal hypothesis test. It gets us ready for it, so to speak. Okay, so now I have to make a confession. To 100% prove that I'm right, we have to treat the F statistic like a test statistic. And to be clear, we actually can do that. There's a hypothesis test that uses the F statistic, but that's coming in other episodes. For now, you just need to know that I ran a hypothesis test and found out that I was, in fact, correct. Ha! But if you want to know how I did that, you'll have to tune into the next episode. In the meantime, Taylor is a good reminder that variability is all around us, and a lot of times we have questions about how that variability compares across and within groups. Like, does income vary more within education levels or across them? Do ticket prices vary more within genre or across genres? Just don't talk to me about Eras Tour prices. 6 nights in Toronto, $1,000 just to get in. Statistics helps us answer these sorts of questions, cementing connections and opening up new possibilities we might not have even considered. Like, what if she never releases the next album? If you're enjoying this series and are interested in taking the full Study Hall Real-World Statistics course and earning college credit from ASU, check out gostudyhall.com or click on the button to learn more. And if you want to help us out, give this video a like, smash that subscribe button, and comment your favorite Taylor Swift song or album. Thanks for watching, and see you next time.